Our destination is a small island of Mauritius. The Republic comprises a group of islands in the southwest Indian Ocean, consisting of the main island of Mauritius and the outer islands of Rodrigue to the east, Agalega to the north, and Saint-Brandon to the northeast. Today we concentrate on the island of Mauritius itself with a total land area of 1,864 km squares with about 150 kilometers of coast and beaches. The topography of the island consists of a higher central plateau, which rises to its highest point of 828 meters in the southwest. To the north, the island drops and flattens down to form the extensive northern plains, extending down to the west coast. The east coast has a very narrow coastal plain with a relatively steep profile. This topography has an important impact on climate. In fact, we have 75 microclimates. Mauritius has the highest population density in Africa, with 1.2 million people. However, we have an aging population and we expect a slight decline in the near future. The island enjoys an upper-middle income diversified economy based on tourism, sugarcane, financial services, and so on. About one-third of Mauritius is built up. These include roads and reservoirs, residential areas, commercial buildings, industrial buildings, and in the coastal zones you will find a lot of high-end hotels. This year we are experiencing a boom in the construction sector, which is expected to continue to grow with increased urbanization. We usually make buildings that will be resistant to cyclones, humidity, and saline water. However, those living under the poverty line tend to live in small ad hoc houses made up of corrugated iron. Mauritius has a mild tropical maritime climate with a warm, humid summer extending from November to April and a relatively cool, dry winter from June to September. The mean temperature is 24.7 degrees during summer and 21 degrees during winter. The adverse impacts of climate change are already being experienced. Our climate records over the period of 1951 to 2014 show a warming trend of about 1.2 degrees. The warmer, wetter summer is controlled by the Intertropical Conversion Zone. When the ITCZ reaches Mauritius, the island may experience tropical cyclones. The wet and dry cycles associated with ENSO episodes can also have serious impacts. Variations in the intensity and timing of the movements of the ITCZ from one year to the next causes interannual and interdecadal variations, making it difficult to identify long-term trends. However, our records show that on average, precipitation has decreased by 8% between 1950 and 2008, affecting our recharge zone and with more pronounced drying in the north and west. Our sea level records indicate an accelerated rise of 5.6 mm a year since 2003, much higher than the global average of 3.2 mm a year. The main island of Mauritius has been lucky in that most of the recent cyclones have not landed straight on us. However, cyclones have become more intensive and unpredictable, as exemplified in April 2016 when the region experienced its strongest known cyclone. Fantala formed on 11th of April to the south of Diego Garcia with a maximum estimated gust of 345 km per hour. It affected our northernmost island, Agalega, where residents were evacuated. Aside from cyclones, over the last 5 years, a number of flash floods have occurred, such as on the 30th of March 2013 in the capital city, Port-Louis. 11 people lost their lives, the highest recorded fatalities in recent times. This event was one of the factors that led to the creation of a National Disaster Risk Reduction and Management Center. The following climate projections are based on the 5th IPCC report and its accompanying Representative Concentration Pathways (RCP). Where relevant, projections based on the 4th IPCC report and its accompanying special report on emission scenarios will also be used, as AR5 held less details for seeds due to dearth of data. According to the latest IPCC special report on 1.5 degrees, we are currently headed towards the higher ends of its graph. We will be using scenarios RPC 8 and 4.5, as well as SRES A2, A1B, and B1. Projections made on the basis of AR5, RCP 4.5, and RCP 8.5 indicate an increase in temperature of up to 2 degrees for the period of 2051 to 2070. These graphs show the spatial patterns of projected change in mean annual temperature for 10-year periods in the future under the SRES A2 scenario, characterized by a divided world, slow demographic transition, and delayed development of renewable energy, which is probably where we are headed. As you can see, the island and the surrounding ocean will warm from somewhere between 1.4 degrees to 2.1 degrees by 2060. In terms of rainfall, seasonal cycle projections for RCP 4.5 and 8.5 show increased erraticness, with drying in December and January and increased precipitation from May to October. As you can more clearly see in this SRAS graph, overall annual precipitation does not seem to change much, but you can see the amount of uncertainty there is concerning precipitation in this part of the world. Sea level rise is hard to predict in Mauritius, as we only have 30 years of data showing a rising trend, while the IPCC recommends 50 years for a robust trend. Thus, we can use a global mean sea level rise for 2081 to the end of century relative to 1986, which will likely be in the range of 0.32 meters to 0.63 meters for RCP 4.5 and of 0.52 meters to 0.98 meters for RCP 8.5. As you can see in this 2016 World Risk Report, Mauritius is at the top, ranking 13th most at risk of natural-related disasters. Luckily, our economic development means that we have fairly good means for adaptation at this stage. Our economy is very dependent on the tourism and fishing industries, and both necessitate a healthy marine ecosystem. This is under threat from ocean warming and acidification, which will result in coral bleaching and dying, affecting all marine life. Mass coral bleaching were observed in 1998, 2003, 2004, 2009 and 2015 and are projected to occur more frequently. Due to sea level rise, we are already experiencing important beach erosion, which is only going to worsen, while our natural defenders, mangroves and wetlands are being destroyed by human activity. These two tables show the current and future infrastructure identified by the government at risk of inland flooding, coastal inundation, and landslide hazards. Key infrastructure includes schools, health centers, hotels, police stations, and industrial sites. The container terminal is particularly vulnerable to the impacts of severe weather systems, such as during the 2013 floods that led to a stoppage of port operations for 21 days, resulting in a shortfall in revenue of about 3.9 billion Mauritian rupees. Though we have aquifers, lakes and rivers, as we are a small island, we still depend a lot on rainfall and are vulnerable to droughts. The northern flat plains have been water-stressed since about 2011. This means that a bad year in terms of rainfall could lead to a more severe drought and its consequences for human life and nature. The vulnerability of the agricultural sector is expected to increase in the coming decades. Warming affects soil moisture and will lead to a shift in agricultural zones, while sea level rise will result in salinization of water used for irrigation in coastal zones. Reduced rainfall and an increase in evapotranspiration due to warming may lead to a decline in agricultural production by as much as 20 to 25% in the medium to longer term. With an average of 7.5 million tourists per year, important diseases are likely to be a major transboundary issue. Circumstantial information links the rise in temperature to an increase in vector-borne diseases in Mauritius. This was observed for the first time in 2006 with an epidemic of chikungunya. It was followed by successive outbreaks of epidemics of dengue. This is likely to get worse and put additional pressure on already strained public health services. Furthermore, our imports and supply chains are likely to be affected. As a small island, we must import a lot of our goods, such as fruits and vegetables, from the South African Western Cape, which is going to experience increased drying. This could impact our food security and overall economic well-being. As we have seen, as a small island nation, Mauritius is highly exposed to climate change and its adverse impact on ecosystem services and socio-economic development. Most at risk are the marine and coastal ecosystems and related economic activities, freshwater availability, seawater intrusion, and food security.